Welcome to John's Maths book. This video is going to provide an overview on quadratic equations and will be referred to in future videos. Let's take a look at a quadratic equation in standard form. As you can see, a quadratic equation takes the form of y equals ax squared plus bx plus c. It's a second order polynomial equation in a single variable x. Second order means it must have an x squared term, but it can't have an x term which is an order greater than 2. So for example, we can't have an x cubed term. If we plot the graph of a quadratic equation, we see that it has a parabola shape. This can fall from the left and rise to the right, as seen here, or rise from the left and fall to the right, as seen here. We can always determine which way the graph rises and falls by looking at the coefficient a of the x squared term. If a is greater than 0, so if we have a greater than 0, then we have a graph which looks something like this. And if a is less than 0, we have a graph that looks something like this. Why do we solve quadratic equations? The plotted graph cuts the x-axis twice where y is equal to 0 at coordinates r and s. So let's take a look at where r and s are on these graphs. So we have r is here and s is here, and in the second graph we have r and s. So that's where it cuts the x-axis, so where y is equal to 0. These coordinates are known as the roots of the equation. We solve quadratics to find the roots of the equation. Another reason we solve them is to find the vertex, or the point at which the graph turns upwards or downwards. So in these examples, we can see where the graphs turn up and down, and at this point here on the first example at coordinates h and k, and at this point here coordinates h and k. Now let's look at different ways we can solve quadratics. One method we can use to find the roots of a quadratic is to use the factoring or factorizing method. This method attempts to find two numbers r and s which when multiplied together give a times c, and when added give b. So in our example here, r multiplied by s will equal a, the coefficient of x squared, multiplied by c, the constant in the quadratic, and r plus s will equal to b, the coefficient of the x term. When factoring, we convert the quadratic from standard form into the form shown here. So y is equal to a into x minus r multiplied by x minus s. Now we can use this to find the roots of the quadratic by solving the two equations x minus r equals 0 and x minus s equals 0. So in this case, one of the roots is x equals r, and in the second case, x is equal to s. Now we'll take a look in more detail at the factoring method in our next video. Another method for solving quadratic equations is known as completing the square. So if we take a quadratic in standard form ax squared plus bx plus c, and we convert it to the form y equals a into x minus h all squared plus k, this is known as completing the square. If we plot the graph of a quadratic, and we can see in this case it falls from the left and rises to the right. When we complete the square, not only do we find the roots of the equation, so where the curve cuts the x-axis, so therefore y is equal to 0, but we can also find the point at which the curve turns. So in this case, the point at which the curve turns is our coordinates h and k. Now, in the third video of this series on quadratics, we'll be looking at how we complete the square. Another way to solve quadratic equations is to use the quadratic formula. If we take a quadratic equation in its standard form of y is equal to ax squared plus bx plus c, we can use the quadratic formula to find the roots of the equation. So that is where the curve crosses the x-axis at y is equal to 0. Now the formula for doing that is x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now in this case, a is the coefficient of the x squared term, b is the coefficient of x, and c is a constant. If you like these videos, then please share, like, and subscribe. And in our next video, we're going to be looking at the factoring method for solving quadratic equations.